try and avoid my usual talk and give something slightly different. What I want to look at is the foundations of coral reefs in terms of, answering the question, do scientists look but not see? Hopefully that'll become apparent in a short while. In terms of ecosystems, we look at something like a coral reef and we see it there, and the system as it sits, it delivers services. So we can talk about ecosystem goods and services, and the services are delivered to not only us, but it delivers things to the animals that live there. So the ecosystem delivers basically structure and things for the fishes and all the other organisms that we find. In a more formal way of looking at it, you talk about ecosystem services. What provides for those services is the ecosystem itself. What maintains the ecosystem, however, is ecosystem functions, and within those functional groups. So these are terminologies, but what does it really mean? A functional group is something like corals. Corals provide ecosystem function, and the function corals provide, amongst other things, is three-dimensional structure. So the corals are the functional group. They provide structure, that three-dimensional matrix that you see, and that provides what you need for the ecosystem to continue to provide us with the services, things that look nice and pretty for tourists, or the fishes that we want to go and catch. So the same kind of thing would apply to a house. So a house, for us, provides services, and you can look at it, and it's not an ecosystem service, but it's a family service. It provides shelter, it provides somewhere to sleep, it provides toilets and all the essentials of life. And you can value these, so you can look and say, well, that house is worth so many dollars in terms of the services it provides, and you can do similar things on the reef. But the value of those services that you would look at in something like a house all depends on the foundations. As soon as you see the foundations, suddenly the value you had in your mind earlier might well be changed. Now, you might like living on top of stacks of wood, but the foundations themselves really do come into importance once you try to look at the system. And that applies equally to the reef. So the question I'm looking at is, what are the foundations like for the coral reef? Does it have good foundations, or are they a bit rickety? Now, the thing in this is, how do we actually examine the foundations? What do we actually do to understand the foundations of the ecosystem that's out there on the barrier reef? And the answer is we do exactly the same as we do with a house. So if you go and have a house and you want to know the foundations, you have a visual inspection. So you get some guy with a flat hat, comes around with a screwdriver, pokes it a bit and says, oh yeah, it looks good, mate, you can buy it. But the coral reef, what do? Well, we do something professional. We go around with scuba tanks and we write things down with a pencil and say, oh yeah, looks good, mate. It's okay, we'll dive on it. We do a visual inspection in both cases. Now, I worry about that because visual inspections are only looking at the surface. There's a lot more going on. And if you were to look at a house, you would find there are signs and clues that not always things are going as well as you think. So you look on the outsides and you peel things away, and all of a sudden you get these signs and clues, and then you find the culprits and the reality. And if there's a hint of bitterness here, yes, that is my back garden, and what I thought was foundations turned out to be Mother Nature's paper mache, which is termite turds. My foundations are gone, but at least I knew because I looked beyond superficially what you could see. So the GBR, hopefully, we're in better shape than this, and the foundations there are good, but I worry about what it is we actually see when we go to the reef. So if we take this as an example of what the reef looks like, what you actually see when you go on the reef is that. Now, you might say, oh, look, that and that, much the same. And it is. It's like those, Dave's lost it finally. Maybe true, but there actually is a difference there. And would you believe there's a 50% difference in the number of fishes on those two photographs? Half of what you see on one isn't present on the other. So yes, there are things missing, and that's exactly what we have when we go on the reef. We go and survey things, and what do you see? You see what you expect, you see what you're used to, and you miss half of the individuals that are on the reef. So the question that's come from this, 50% missing, does it really matter? Surely 50% is good enough. If you can see patterns in that 50%, the 50% that's missing really doesn't matter, and we can go on and we monitor the reefs and we think we're okay. What I worry about with this is that are we actually monitoring things that are important for those foundations, or are we just monitoring like the outside of the house? The paint works nice, but the foundations may be rotting. So what do those 50% represent, and what are the threats to the reef? Well, one of the biggest threats, and one of the most widely recognized at least, are these phase shifts, where people say, the reef, if things go wrong, it can go from being coral-dominated to algal-dominated. But, you know, let's face it, surely that's not going to happen on the Great Barrier Reef. It's the best managed reef system in the world. We're going to be in reasonably good shape. So this is almost academic. So I'll show you a typical photograph of the Barrier Reef, and that's what it's like. And you go, oh, come on, it's not really like that. And the answer is, yes, it is. There's lots of reefs out there like that. We don't choose to take photographs of them, because as you can see, you don't find that on a postcard on, you know, Green Island. But that is a kind of reef that's out there in many places. Is it atypical? Well, no. What we did is we did a series of transects, 528 transects in the northern section, central section, inshore, offshore, all over the place. And of those transects, 21% macroalgae was a dominant component. 14% of them had more than 50% macroalgal cover, and 1 in 4 had more macroalgae than it had coral. So macroalgae is a living representative of types of reef out there. So macroalgal-dominated reefs do exist on the Barrier Reef. So where are they? Well, the answer is they're mainly inshore. What we're dealing with is inshore reefs with lots of macroalgae. So if we look at it like this, we say, well, gee, what is this? Is this the signs of a rotting reef? Are we really looking at termite tracks? Is the Barrier Reef rotting from the inner shore out and slowly unraveling? And what we're looking at with these macroalgae is basically a white-antered collapsing reef. And the answer might be yes. Now, I'm not saying it is, but we've got to be careful. I'm kind of concerned by this. So the question from this is, well, where are the herbivores that are supposed to be eating this? I mean, surely we're well protected. Surely the herbivores are going to be there that's going to go in there and remove the algae. Well, they are, and they're in reasonable numbers, but what's interesting is that most of them are in that 50% that's missing. So that 50% we don't see, there's a parrotfishes that will prevent reefs going to algae, macroalgae, and then there's a whole other group that enable it to go from macroalgae back to turf algae. Those species you very rarely see. So that particular component is very vulnerable because you don't ever see it. You go diving on the reefs, and as soon as you arrive, those fishes, they disappear. So that 50% does contain some important things. Now, there's some really good news in this, in that the federal government finally, in terms of its evaluation of the reef, has identified herbivores as being particularly important and worthy of protection. As far as I can see it, it's the first time a species has been protected for the role it plays in ecosystems. Not because it's overfished, not because it looks pretty, and not because we've driven it to the edge of extinction, simply because of something it does for keeping the ecosystem in good shape. Now, for me, that's a very reassuring and a very positive step, and I hope to see more of it. But the fact that they're considering putting it on in terms of herbivores for protection, it's good. And this is based largely on the seminal work of Laurie McCook and Terry Hughes. That's why they're there. Their early work on herbivores identified the need, and the government now, we can identify the species that are important. We've got the package together to be able to implement some really useful protection. So things are looking positive, but this is only a small proportion of all of those things that we've missed. So if that's a few of them, what about all of the rest? What are they doing? Well, when you look at the reef, half of them go missing, and there's a reason that you don't see them. And that is because they're not that easy to see in most cases. So, as an aside, any guess how big an average reef fish is? Look, there's a photograph of one there. There's an average-sized reef fish on that slide. And, of course, the average-sized fish is there. On the Barrier Reef, the mean size of a reef fish is about 45 millimeters. It's about end of your finger. The modal size class is 35 millimeters, and that little fish photograph's about 30 millimeters long. So the vast majority of fishes on the Barrier Reef are small. So when we think of reef fishes, what we are thinking of is big reef fishes, because most reef fishes ain't big. So the question is, these little beasts, what on earth are they doing for the ecosystem? Does it matter? you know, gee, they're little, they're easily overlooked, so surely they just do nothing. Why worry? And the answer is that they do everything, and they do everything for the reef and for you. And what do? They die. They die in vast numbers on a regular basis. And it's precisely what the reef needs. So how do we know that? Well, this is Marcel Debchensky's work, one of the students in the Center of Excellence, looking at mortality rates. These things, based on tagging studies and otolith studies, are dying at the rate of 8% per day. So that means that when 10 little gobies wake up in the morning, only 9 of them go to sleep that night. Serious stuff for them, but what are the implications in terms of, you know, what does this actually mean? Well, it means they don't live very long. This little fish is still in the Guinness Book of Records, the shortest lived vertebrate that there is alive. Its maximum lifespan is 59 days. The reason it only lives to 59 days is because they keep getting killed. They don't make it. If you keep them in captivity safely, they live for a long time. On the reef, 59 days, the oldest specimen we found. 33 days on the reef. That's a little over 5 weeks, is the oldest fish in terms of the time spent on the reef. Now, so these things they're dying a great deal. There's lots of them. But is there anything else that they do? Well, the answer is yes. They contribute a great deal to the system. Now, in terms of biomass, they're only down there 1 or 2%. It's mainly gobies that we're looking at. They're the thing that's driving the system. But, you know, cryptic taxa, these things we miss about 4% of the biomass. So it's not much. So if you went fishing for them, you wouldn't need to take a bucket, you just take a, you know, cup. But the numbers of them in there will be huge. There are vast numbers of these things out there. The mean number, about 14 individuals per square meter. So if you're standing there, immediately beneath you, there's about 14 of them. You won't see them, but they're all there. But it's what they're doing there that's really important. While they're there, and this is what Marcel calculated, is they're growing. The amount of mass increase by these individuals per week is something like 9%. Now that means that these little gobies, the things that you don't see, are accumulating more mass than the surgeonfishes, those big things that swim around feeding, or say the coral trout and all their relatives, plus all the butterfly fishes put together. So these are seriously important little growers. And in terms of length, they put on more length per week than all of the other fishes put together. So what are they doing on the reef? They're growing and they're dying. That's what they do. So in effect, what they are is they're the powerhouse of the reef. They're producing the energy, they're pulling it in, turn it into these little things that are just irresistible to eat. They're Tim Tams. They sit there, and that's what the reef needs to keep going. So these things, they're there, they're producing all the energy, they're stepping up through the system, but are they smeared all over everywhere? And the answer is no. They're wonderfully selective. So if you look at, and this is a couple of study locations, one's in the tropical East Pacific, the other one's on the Great Barrier Reef. This is work that was done by Alonso Gonzalez looking at these cryptobenthics. And if you look at the East Pacific and the Great Barrier Reef, fundamentally different faunas. There's nothing like each other in terms of the taxonomic composition, but these little small fishes you don't see have the same message in both places. If you go over, if you're on the Great Barrier Reef, you see very, very different faunas in different habitats. Coral heads have got one fauna, other rubble habitats have got another fauna. So they divide up the world. The tropical East Pacific is even better. Don't worry too much about the symbols, but if you look at these little circles on the left-hand side, what this is telling you is that if you go to a coral head, it's different from a rock. But what's really nice in the East Pacific, the top of the rock has got a completely different fish fauna to the side of the rock. So these things are sensitive to the orientation of the lump of rock that they're sat on. So they divide up that world very, very finely, and they respond to the environment that you find. So what we have is, in effect, high turnover rates, fast growth rates, and extreme sensitivity to the environment. We've got brilliant indicators of environmental change. So these things are going to tell us how the world is changing. So given that there are problems going on and reefs are in trouble, these are going to be the group that can demonstrate resilience and also demonstrate recovery because they're so dynamic. So this brings me to a long-term study that we've been doing, And that's looking at these missing fishes, these invisible fishes, using anesthetics. So what we do is we get a double bed mosquito net, cover a lump of reef, and look at all of the fish inside. Every single individual is collected. So we know exactly what's on the reef. We've been doing this for many years now, maybe a couple of decades, and we were able to look at the effect on these populations of the 98 bleaching event. So this is the big one we've heard about today. If you look at the grey line, that marks where the 98 bleaching event came in. It absolutely devastated these study sites. It knocked the corals around. Some of them are in real bad shape. But what was the effect on these little invisible fishes? The answer is, in terms of species richness, it went up, it went down, but there was no real change. In terms of the number of individuals, if anything, the reefs looked better after the bleaching event than they did before. So in theory, the bleaching event's not that big a deal for fish. I mean, we worry about the corals, but fish are the real... No, we worry about the corals. Sorry. Fishes are doing okay. So the message didn't seem to be that worrying until we looked at what was going on underneath. And this is the population structure. So this is a plot showing what the various communities of fishes look like through time. And at the beginning, in the 90s, before the bleaching, we had a community that's characterized by coral-associated fishes, quite attractive. It was nice in its own way. After the bleaching event, it took about a year for it really to click in. We got a different fauna, and this fauna was quite unusual. It was nothing like the one that had been there previously. And this was characterized by a degraded system. It was things that fed on detritus more, it's things that like rubble. It really was a degraded system in terms of the fish fauna. So there was lots of them, but they just weren't that nice. You can even see from the colors, they weren't that attractive, but they were still doing quite well in terms of numbers. So this was well and good, and we've published this, but we had the opportunity to get some coral data. And finally, on the exact same study site, this is thanks to Andrew Baird, who collected this data, we have matching coral data now. So we can see what happened to the corals. And indeed, on the left-hand side, the grey bar marks the bleaching event. There was a drop in coral numbers. This is number of colonies, before and after. So total live coral went down. And on the bottom, I don't know if you can see it, it's at the bottom of the slide, the acroporas dropped to about a quarter or a fifth of what they were originally. So the corals on those sites were really hammered by the 98 bleaching event. But, and this is the good news, it's all coming back. So the coral numbers to date look as good as they've ever looked. In fact, recovery appears to be brilliant. So now what we've got is corals coming back, we've got coral-sensitive fishes, we've got these wonderful indicators. This is the chance to show how reefs can regenerate and go back, and that it is a dynamic system that you can go down, but you can bounce back. So we started collecting the data, and this will demonstrate the capacity of reefs. The following year, 2005, this is once the corals had got up to their good numbers again. Instead of seeing things going back where we thought, it went to a new area. So we got a different fauna, one with lots of planktivores. So we started to get a different kind of fish fauna. So try another year, 2006. It's still up in this new weird place. 2007, it's still there. What this suggests to us is we've got hysteresis. So the path that the thing takes to decline is different from the path that it's going to take to recover. So recovery is following a different path. 2008, it's getting close. Maybe we'll go back to that coral original form. And 2009, no, it's back in scunch. The reality is, what we've got, oh my God, I've got to go fast. Thanks, Sean. We have probably a degraded system, and it's a highly variable one. It's not going to go back. It seems as if it's stuck in this area. This is 10 years post-bleaching, 5 years post-coral recovery, and the fishes are still in this degraded state. This, for these fishes, is 30 generations. Now, 30 generations is a huge amount of time. In human terms, 30 generations is the Dark Ages. Joan of Arc was stood in front of that fireplace telling the Dauphin he should think about kicking the English out of France. That's how long ago it is, 30 generations from us. 30 generations of gobies, they're still wallowing in the degraded state. It's a long time in lifespans, it's a long time for the system. So when people tell you reefs are doing well and they're regenerating, and they look at fishes like this, the ones you can see, that hasn't gone through a single or maybe one generation since the bleaching event. We may have yet to see the impacts of the bleaching event on the vast majority of fishes that are living on the barrier reef. Some of those fishes are probably, well, I used to say they're older than me, but I'm getting too old to say that. But some of those fishes live a long time. They live for a long time. Right? So, when we get to the end of this, the question, the foundations, how are they looking? The answer is, some of the foundations, we've found them, we've identified them, and we're starting to protect them. It's looking good. Others, they're shifting. The foundations are shifting. They're not the same. They may still provide some of the essential services, but they're not the same foundations. And for that, we've got to be a little concerned. So the overall question, when we're looking at the foundations of the reef, it's not quite the same. But this is good. It gives us a clue, and it perhaps tells us what we should do. We shouldn't be planning for a return to the past. I don't think it's ever going to be the same again. But what we should perhaps be doing is planning for an increasingly unstable and uncertain future. Thank you.